All right, I think we're going to start. There's still some people filing in, but got a lot to talk about, and I want to tell you guys before they kick us out of here. So I feel like we should probably get going at some point. Let's do that. I got the right number here. Let's see if I switch this correctly. There we go. Good morning, everyone. Welcome to the Apex No Limits session. My name is Josh Kaplan. I will be your guide for the next half hour and change about what we're doing with limits on the platform, how we think about them, and some things that we're working on in the future around limits. And before I do anything, wherever I go, I am followed by the safe harbor slide. You don't have to try to read this now, but it essentially says make all purchasing decisions based on publicly available information, not on any forward-looking statements that I will make today. Again, my name is Josh Kaplan. I'm a product manager at Salesforce. I work on the Apex team and with the platform development tools teams. And I am fortunate to be joined today by Suhail Masood, a partner of ours from DirecTV. He'll be joining us to tell a story about how they've been a partner with us in building out some of the exciting new features that I will be describing today. We're going to talk about here our philosophy on limits, what we think about them, how we view them, some of the refactoring that we've done with the limits that you deal with today, and some of the brand new reimagining of how we're going to handle service protection on the platform so that it's something that can get out of your way and you can really be in a no limits environment. And that's the point at which we're going to get to hear how one of our customers is working with this today. So limits, they just look evil. They look bad. When you first see them, you just assume these are bad guys, right? These are bad guys. They're in the way. Every time you're trying to do something, there they are to stop you. And so you're just assuming these are the bad guy. But eventually you realize, no, they're actually not. They're a good guy. They've been with you all along, protecting you, helping you do the right thing. They're there for service protection. They're there to make you a more efficient coder. And crucially, they're there to make everybody else on the platform an efficient coder so that they don't steal resources by being lazy and sloppy that would get in the way of the business processing that you would like to do. So they're the good guys. And that's what we're trying to get to, the point that you say, you are our friends. Thank you, Limits. Thank you for everything that you do, and thank you for being there to help us do what we need to do. Why do I have this picture up here? What does this mean? That's how I want limits to be. I want them to be a runaway truck ramp. You ever drive through the mountains, you see this when you're driving, and going down, you think to yourself, runaway truck ramp. That's kind of interesting. I wonder whoever needs that. I wonder who uses that. That would really be a bummer. I guess it's a good thing that it's there. And then you just keep going. You just keep going right past it, and it's sort of out of your field of view. It's not something that you're really paying attention to or trying to dodge or avoid. It's just there, and you notice it, and then you just keep on going. But when you need it, you're going to be very excited that it's there. So if you write yourself an infinite loop and you forget about that, we're going to tell you. If you go do something that just spins the database for hours and hours, bringing back 1 million records when you meant to get 10, we're going to stop that. So when you make a mistake, we'll be there to help you. We'll be there to give you a backstop so that you don't go past where you want to go. And again, crucially, so that nobody else does the same thing in the environment, in the multi-tenant environment that you're working in. So this is where we're heading with our limits. And in that spirit, we've been working on this for quite some time now. On the left is a list of transaction limits we had in spring 13 release. And on the right is a list of the same limits as they're going to exist by the summer 15 release. And this more or less coincides with my time as the product manager here, so I'm very proud of this. We've been working on this very, very slowly, chip at a time, one per release, making sure we do the requisite diligence such that when we change a limit or get rid of a limit, it doesn't knock anything over. So we can't just go at this one big bang approach. But if we were to have done this in one release, we might be in the keynote tomorrow, right? This is a huge difference between what you had to deal with 2 years ago and what you're going to be dealing with next summer. A few ways that a few tools we've got in our tool belt. We can remove limits, which you like. We can relax limits, so make them easier for you. And we can restructure them in a way that makes them easier to deal with. And so I'm going to talk about all those things and what we've done in the last couple of years. Before I get there, though, a little story about how limits work and what we think about and what we have to deal with when we're working on these things. Everyone just says, raise the limits, just increase them. It'll all be good. So this particular limit, number of classes you can do in a single deployment. When Apex was written originally, the limit was 500. You could have 500 classes or triggers in any one deployment. And at the time, it was assumed that that was probably a lot. That was something that people wouldn't have to worry about too much, which was true until 2 years later, customer called and said, 500 is not enough. I need more. I have more classes than 500 that I need to deploy at a time. I need some relief here on this limit. And so at the time, The limit was increased to 750, 50% increase. And we said to ourselves, this is probably good. We're probably going to support most of our customers with that, which was true until exactly two years later, where in 2011 we had a problem where someone called in and said 750 is not enough. I have more classes and more triggers than 750. And so naturally, what did we do next? And you go, no, we took the limit to next. We just said, forget it, we're doing this. We're going to put this limit so high that we're not going to have to deal with it. We don't want to deal with this anymore. 5,000, it's not going to be a problem, so there we go. Which, of course, was great until earlier this year, when another partner said, we're getting pretty close to that 5,000 limit. Is there anything we can do about this? Or there's some things we should think about. And so it's this thing where we just could keep spinning the dial as much as we want, but no matter how many times we spin the dial, somebody is going to find a use case that's going to go into place. And I call this Moore's Law. Now, this is not Moore's Law. Gordon Moore famously predicted that every 2 years, the number of semiconductors you'd get onto a chip would double. This is Moore's Law, where every 2 years, no matter what we set the limit at, you guys are going to want more. And so that seems to hold true here. So this is the kind of stuff that we can't just spin these. We have to think, what is this limit really protecting, and how can we change things? So we think about that a lot. Do we need this limit? Is this the right limit? Are we protecting the right resource? Let's go and look at some of the things we've changed already. Refactoring of the current limits. So one thing we can do is just remove the limits entirely. Everyone loves this, right? Limit be gone. It's perfect. When the system is stable, we take the stabilizers off. And we can do that sometimes. So some examples we've done in the last couple years are the old describe call limits. These were originally a database query, so this is essentially making one more query to the database. And we started caching these, so if you call them once, we just give you the same result again. So we don't need this anymore. It's not really protecting much because it's one query. And what's funny is that was how you guys used to work around this. You would make static variables and you would cache it on your end. Now we're doing that for you. So we just took your best practice and we made it our best practice. The maximum size of a callout, request to response. I had to look into this recently. I was quite amused. At one point, this was part of the heap limit. That's where it belongs, I think. It's part of the heap limit. If you have how much memory you can use is how much you should be able to send out. And someone called and asked for more, because of Moore's Law, right? And they said we need more for our callouts. And we thought, we don't want to have to increase the memory for the entire org. Let's make a separate thing where we can increase the size of a callout. So the heap limit was 3 megabytes, and this limit stayed at 3 megabytes. And then we increased the heap limit to 6 megabytes, and we increased it to 12 megabytes, and no one remembered to increase the callout limit size. That was put in by a different team, and kind of those people had moved on to other teams, and no one remembered it. So it got sort of abandoned, and it seems kind of silly that we would have a separate limit for that that's lower than our heap limit. So we're going to get rid of that. We're going to consolidate it back into the heap limit where it belongs. So the good intentions don't always get you to the end result you want, so now we're back where we should have been in the first place. And the maximum number of concurrent calls to a single house, no one's ever hit this. We have so many other things that stop you before you get to that point that this is truly redundant. So we're going to get rid of this one as well and make it so that you don't have to think about these things. 3 limits, you're not going to think about it all anymore. You can just ignore them, kick them out of your memory, and they are no longer something for you to worry about. Another thing we can do is relax the limits that we have. We can take the numbers we've got and we can spin the dial like before. So this over here is my daughter, Naomi. Naomi is very soon going to be a big sister. In fact, it's pretty imminent. There was some question as to whether I was going to be able to be here today. But when we found out that she was going to have a little brother, we needed to move the crib to the other room. So Naomi got herself a big girl bed. She's very proud of this. And that old crib, she was right up against the headboard. She was kind of fit in there pretty tightly. But as you can see now, she's swimming in it. She's got all the space in the world, and she's very relaxed. So we're relaxed here. So we've done this for you guys in some of your limits as well. We've given you a whole bunch more space to do the things you need to do. 4 times as many scheduled Apex jobs, you can have 4 times as many things scheduled. Since we've increased that limit, I used to get requests all the time. I've got maybe 3 or 4 requests since we made that change. Number of batch jobs you can enqueue. We built a whole new system called Flex Queue. We're going to be releasing in the spring. That changes the number you can have from 5 to 100. I don't even know if that's going to stay. We may even increase that. But now you can have a lot more jobs lined up in the queue to run in batch. Now here's another fun one. The start method, the query you run in start method used to have a 2-minute timeout. We would retry your start method 4 times. So you essentially got to run 10 minutes worth of queries if you had a long-running query. And because of the way the database works, it caches your results. And so a lot of the results from that last query were still sitting around and ready for you. So you could more or less run a query that took 10 minutes, just broken up into 5 blocks over the course of 4.5 hours or whatever it took to retry it all. And again, that seemed kind of silly. So we ran a bunch of performance tests. We figured out that one 10-minute query with no retries was not going to harm us any more than 5 queries at 2 minutes each. So anyone who runs batch processing over large data with incredibly complex queries, You've probably been appreciating this for a release or two that we've had it out there. Now, this limit is one I plan to move into the removed limits category as soon as we possibly can, because this one is probably going to turn out to be redundant. We have a number, an aggregate timeout of 120 seconds you can do in all your callouts. So does it matter if you do 10 callouts that take 10 seconds or 100 callouts that take 1 second? It's kind of the same weight on our side. Weight both in sort of how much it costs our system and how much time we're waiting. We're being cautious because we don't want to break the system. Remember, service protection is number one. But we're going to run this for a couple of releases, make sure that this is fine, and I think eventually this is going to prove to be redundant, and we're going to use that aggregate timeout and have no limits on the number of callouts you make. At that point, it's all on your back-end systems that you're integrating with what your true governor is going to be. And one other thing we're doing in the next release, we're increasing the number of @future calls in a transaction from 10 to 50. Hold on to this one in your memory, because I'm going to talk about this one in a moment. And here we are at that moment. So restructuring of limits. So sometimes we just have a lot of different limits that work on the same resource, and it's nice for us to be able to move them together into a single. Take all the disparate parts and put them together as one, and it's a better thing. That's my Voltron analogy, if any of you know Voltron 5 coming together. Anyway, we had two limits that were more or less doing the same thing, but they were separate. 24-hour limits to number of @future calls and number of batch calls. They were calculated differently. The future calls is based on number of licenses, and the batch calls is based on a flat number. So large orgs would say, I need more batch calls. I hit your cap because I got lots of data I'm running. And small orgs would say, I need more @future for some peak period that I'm doing some processing. And I would get calls to help people out with these limits and relax them for them. They're both doing the same thing. They're both putting an item into MQ and pulling it off of MQ. So we said to ourselves, why are we making these separate? So we put them together. We now have a single 24-hour limit for both of them. And I have not gotten a single request for an increase since then. So we've been able to right-size this for everybody by consolidating there. Thing I mentioned before, @future calls, we have a bunch of different asynchronous calls you can do from a transaction, so we don't need separate limits for all of them. We've just added this queuable interface some of you may be familiar with. It's kind of like @future, so they're almost exactly the same, batch calls and schedule calls. We're going to make one limit. You don't have to think about 5 different things. You can think about one thing. I'm making asynchronous calls. How many can I do? Here's one number. Off you go. Fewer things to think about, easier for you to do programming. Sound pretty good? You guys like it? Awesome. Good. As I mentioned before, we need to do more than that, though. We can't just spin the dials and increase the numbers all we want. We have to really think more about what are we protecting and how can we better protect what we do and give you guys more room to run and more ability to do the things that you need to do processing on our platform. Some of our limits were proxies. They're proxies for the things we actually wanted to protect. They're proxies for the things we actually want to protect because the things we want to protect are kind of hard to calculate. And so the proxy was the easy thing to do, but that makes your life difficult. You'll understand why as we go through this. One you probably remember is the old script counting limit, where you had a certain number of calls you could make, and we counted those very discreetly, 1, 2, 3, 4, up to 200,000, and then you were stopped. That was really protecting our app service CPU, right? We didn't want you to go into an infinite loop. We didn't want you to go start running for hours on end, and so we needed a way to terminate it. Actually, calculating the CPU usage is not easy. So we couldn't do that right away, and actually it was very difficult to get into place. However, the old pattern was wrong because every script statement was treated equally, and they weren't equal. Integer I equals 0, it was not the same as some complicated string comparison or mathematical operation, but they each counted as 1. And I've seen some of your code. I've seen some of the things you guys used to do to try to play around with the number of script statements you'd have. You have one really long line, it would go all the way out to there. And that just seems mean. We were just being mean to you. So script counting is gone, and we're now using a CPU timeout instead. So we're actually truly protecting the resource we wanted to protect in the first place. We're working on for next release, it's going to be the same thing for database. The single most often frequently hit limit on the platform is the number of SOQL queries in a transaction. I protect the logs. For some reason, this is the one that people hit the most. Maybe it's because it's 100 and DML is 150, so you hit it in your loops. I'm not sure. But again, it's the same thing. That query right there counts as one query. So does that query right there, which I'm guessing you can imagine is not going to take as much, is not going to take the same amount of resources as the previous one. These each count as 1 today. I don't want there to be any incentive for you to write that second query if it doesn't fit your actual programming needs. I'd rather you write the queries you actually wanted to write. Instead, count how much cost we are assuming on the database when you do those queries. This will encourage you and all the other people in the multi-tenant world to be more efficient, to write queries that are good, to write queries that are on index table columns so that things are faster, benefit to your user as well as a benefit to the system. So why is this in the reimagining category? We're moving away from things that are discrete and sort of easy to track and consistent every single time to things that are going to change a little bit. They're a little squishy over time. Our app servers may be having a bad day, or it may be peak hours or something of that nature where the same process will take more time. The same query might take more time on the database. You have to think a little differently now when you're working on your programs. It's not going to be something I can prove I'm exactly one statement lower than the script statement limit, so this is always going to run. You're going to have to pay more attention to how much do I really need to do here, and should I move some of this processing off into another place. So changing the way we're thinking about things so that the system is truly protecting what we want to protect, and you get to think about where your processing really needs to be. We're working on that database stuff right now. We're working on exactly what we're going to check. It might be the CPU, it might be some other obscure database. I'm a product manager. I think I'm a developer, but it's database stuff. So I don't really know the exact stuff. We've got a bunch of metrics. We're looking at them, figuring out what your uses of them are, and we're going to figure out the right limits to set for you, and you'll be getting that in, I believe, Safe Harbor slide materialized ahead of me in the spring release. All right, you've all been here before, right? You're at the grocery store and you're waiting in line, and they don't have nearly enough checkout stands open. And the guy in front of you, the guy at the register, it's his first day, and the guy who's checking out right now is paying with a check, right? And you think to yourself, I didn't know that was still legal. It probably shouldn't be. The analogy on our platform is going to be a call-out. A call-out is the check writing of our platform. It can take a second to be fast, but it could take several minutes. And if we allowed people to just run as many callouts to other systems without any sort of limitation as we wanted, you'd end up at this line. You'd be stuck in this queue. No one likes being in this queue. No one likes waiting in that line. And so we need to make sure that when people do call, we want you to integrate. We want you to integrate to other systems. We need to make sure that it's done in a way that isn't going to form a queue behind you, and you're not going to force other people on the multi-tenant system to wait. This required some thinking on our part, and we created a new pattern to change the way that the limiting is done. Today, what happens is this. User at a Visualforce page makes a call out to Salesforce, which is going to say, go into a warranty processing system. And while we're waiting for the call out to come back with a response so we can display it on the page, the thread inside of Salesforce is waiting. It's waiting and waiting and waiting until that call out comes back. At that point, the response shows up on the screen, usually goes about their day. This is all well and good until you have, let's say, thousands of users. They're all making callouts at the same time. Let's say you're a large satellite television provider, as an example. Lots of people that are calling in. You end up with lots of threads that are blocking, and all of a sudden this cloud is a very, very, very blocked up place. So we have limits. We say you're not going to be able to run any more transactions than, I believe, 10 once they're past a certain amount of time. That wasn't going to let people scale, so we needed a better solution. So we come up with a solution called asynchronous callouts. You may have heard of continuations, the name for the pattern. What happens in this asynchronous callouts framework is the same callout comes from the Visualforce page. But when it goes out to make the callout to the other system, threads go to sleep. We take the threads and we just put them on ice. We serialize them down, your memory, all your variables, so that you can come back and get them at a later point in time. So now this way, I can have as many people as I want. I guess theoretically, I don't know if there's even a limit to the number of people we could have, because all of their threads are going to go to sleep too. So while they're running their callouts, we're no longer blocking. We're no longer interfering with the system. Then we're no longer making it so that everyone else is forming a long queue behind them. This will allow us to scale up. This will allow us to add more users, allow to let you integrate to any backend system, whatever the length of that callout is going to be. So to give you a real-world example of how it's going to work, I'm pleased to have on stage with me Suhail Masood from DirecTV. Suhail, take it away. Give me a hand. There we go. This one.
Okay. All right. Can everyone hear me? Yes, yes, okay. All right, so I'm really glad to be here. Specifically, we've been with Salesforce for about 5 years, and we've been experimenting with all kinds of things. I represent the Solution Architecture Group, part of the Innovation and Strategy. And part of our strategy was really to move to the cloud so that we could scale and we could innovate really fast. We could come to market with the name of the game in DirecTV and in our space is to come up with offers really quickly for customers. So to get a new offer into production, we want to leverage the cloud and beat the 3-month cycle down to maybe a week. And so what we did, we started using Salesforce. Here we are. A few things I want to mention before I get into the specific example. Currently, we have over 39 million subscribers worldwide. The key thing that I want to point out here is, number one, in customer satisfaction, according to the American Customer Satisfaction Index. That is very key for the problems that we came up with later and then also resolved. In the US, we have about 20 million subscribers. And I mean, this is just to give you a size of things that we are working with. So the first wave at DirecTV, we started incorporating Salesforce into some of our supporting processes, such as case management, lead management, property management, customer engagement, social monitoring, campaigns, signature capture. Most of these are sort of offline processes, if you will, from our core processes. Essentially, they support what the core processes do. We've made great progress in this. We've been in production with pretty much all of these processes with Salesforce. We've been using pretty much everything Salesforce stack has: Force.com, Sales Cloud, Service Cloud, Marketing Cloud, Site.com, Database.com. So we've had great success in that. So once we started from the strategy and innovation side, once we started getting success in this, we said, okay, now we can move into, we've taken our baby steps, let's move into the core processes. So the core processes for us are basically where most of the volume of our calls are from customers, which is order management. So imagine that you have about 22 million customers. We get anywhere from 600,000 calls a day up to 1 million calls if it's a fight night. We have 46 call centers and growing, and over 19,000 customer care reps, which also fluctuates to up to 26,000. And then we have about 17,000 field service techs that are out there. So back to the customer service, customer satisfaction that I had mentioned, our main goal is to keep innovating and making sure that we continue to be the leader in the customer satisfaction field. So we wanted to bring Salesforce both into order management and into the field services side. Essentially, we wanted to focus on, currently the agents have about 14 different systems that they work with to fetch information, research what's the best package, etc. In all of that, we find, although the agents are doing a really great job, we want to enhance the experience between the agent and the customer. So we really focused on bringing the call flow, scripting and guidance, as well as the Salesforce call flow in the Sales Cloud to the agent so that we can unify the entire desktop experience so they don't have to look at 14 different applications. They have one main area where they can focus, and remove all this other distraction that the agent is facing so that we are completely focused on the agent to customer interaction. So once we brought that in, the first thing that happened is we hit the limits, both in the field tech side as well as in the order management side. So we have, and the reason for hitting the limits is, as Josh mentioned, makes sense. We have composite services. So one service, for example, the 360 view of the customer, is fetching all your billing history, what your devices are, what pay-per-view you're watching. You could ask any questions, so we need to have all that data up there. Scheduling also, we're trying to schedule 17,000 techs with their complex routing algorithms and what they have in their day. And then tailored offers. These are essentially offers customized to you, where you live, what you like to watch, what kind of a customer you are. And then on the tech side, fulfillment and activation flows. basically the tech goes out. We're enhancing the tech's handheld so that they can provide better customer service. So they can, instead of just going and activating the receiver, they can actually, if you want another receiver, you want to change programming, you want to make changes to the last minute order, they could do that via their Android handheld devices. But the point is that all of these services took more than 5 seconds. And in our testing for the first one, once we hit more than 10 of those that ran more than 5 seconds, we started coming down. We worked really hard and with Salesforce and a really close collaboration. And when I say really close collaboration, I mean we were literally in the same conference room for a couple of weeks trying to solve this problem. There were one approach that we were using at that point, which everybody else was using. Use Visualforce page and create a asynchronous callout. Then you have to basically create a soup cache, so you get all kinds of objects into it, and then you communicate back to the browser. And that just didn't satisfy our time limits because we have an agent waiting while this service is, doing its work. And these overheads that we introduced on the Salesforce side and on the browser side, we're adding another 8 to 10 seconds per service call. And the agent can only talk about the weather and sports for so long before they have to give relevant information. So we worked with Salesforce. We provided all the scenarios, and their product team started partnering with us and pushed out an early version of, got us onto continuations early. And basically, as soon as we got onto that, with very little code change, other than removing the soup cache part that we'd done earlier, we were able to run the longer running transactions. And right now, we're in production for the order management side. And we are going into production for the tech side in a couple of weeks. So for us, continuations was the thing that removed the limits and got our core processes into production. And it was a really tight collaboration with Salesforce, and I'd like to thank especially Ketan from that group who really understood what we were doing and what we needed. And we are one of those customers that are just thrashing the limits, and I understand the reason for the limits. It makes absolute sense. One more thing I'd like to say quickly before I hand it back to you. Sorry, I skipped a slide. All right. One of the things that were really exciting that happened is when we challenged Salesforce, saying, look, we can't operate with these limits. We need to come up with something better. They also challenged us back and said, why are your services taking 6 seconds? And we said, they're complex services. And, there's no way. We have like 10 services running. It adds up. It's 5, 6 seconds. They challenged us, and we actually also internally worked hard. And we are completely reimagining how we're tailoring our offers and how we're scheduling. And we are shaving our side down drastically by 70–80% as well. So a lot of the innovation was co-spurred by you guys enforcing the limits as well. So that's what I wanted to share, just a story from DirecTV on using continuations.
Thanks, Sal. Appreciate it. And this is a good example of how we say the limits do make you sort of think about what you're doing and make your code more efficient. So yeah, we had a great partnership, and thanks for working with us, and continuing to work with you as well on my next topic, which I'm quite excited about here. So if you're driving down this road right here, 50-mile-an-hour road, and you're going 51 miles an hour, you think you would be pulled over and given a citation? Probably not, right? They usually give you a little bit of leeway, a little bit extra. So people ask me, what if I just go over the limit, like 101 queries instead of 100, or if I need 12 seconds of CPU instead of 10, do you not have extra processing? Could you have capacity for that little bit extra? And the answer is yes, we do. We do, but it's really, really hard to sort of let everyone go, because you start letting everyone go, and all of a sudden the tragedy of the commons, and there's nothing left for anyone to graze, right? So this has always been a hard limit for us, but we're working towards something that currently we're calling soft limits. It'll probably be a better, flashier name when we actually end up releasing it at some point next year. That's going to help address this problem. So using the concurrent limit as an example, since we were just discussing it, what happens today is we get a whole bunch of people working on system, running on long-running callouts, long-running transactions. When the next transaction comes in, we just block it entirely. Block it entirely. Doesn't matter if it's the same kind of transaction or if it's a completely different transaction. We just block it. This is a hard limit. This is a hard stop. You get a ugly error message up at the user interface, nastygram email automatically sent to the developer. Not the greatest thing, but service protection is important. It's the number one thing. So let's think of how we're going to do this with soft limits. So I've got a few people running a transaction that's taking a long period of time, and everything's all good. When someone else comes in, I'm going to not actually do anything to stop them. I'm going to make a little, like write your name on the blackboard when you were in the 3rd grade and you talk to your neighbor or whatever. We're going to make a little watch list here. So I got my eye on this transaction. This transaction is running for a long period of time. I've seen a few of them now. I'm going to keep my eye on it. When another one comes into the system, put a check mark next to the name, which you probably also remember from 3rd grade. Put a check mark next to the name when you did something again, right? And so as transactions come in, we're going to mark down, okay, now you've been on watch for a while and you're still doing stuff. You are starting to consume more than your fair share of the resources. You're not on watch anymore. We got you on notice. We really are concerned about this transaction. So when the next one shows up, it's not going to run. It's not going to run right away. Instead, what we're going to do is we're going to create a queue on the fly, and we're going to queue that request up, waiting for resources to free up. Resources that are currently held by other transactions on the system. So as more requests come in while you're still gumming up the system with long-range requests, we're going to put them into this queue, this asynchronous queue that was built for synchronous transactions. We're going to throttle. We're going to throttle that particular transaction because it's taking too much time. It could be taking too much time, too much memory, too much CPU. And we're going to throttle it. And when one of these transactions over here finally finishes up, it's going to release its resources, and we're then going to be able to run whoever was waiting in that synchronous queue. So no more email message to the developer saying you screwed up. No more red error message on the screen saying, sorry, you just have to wait. Just a little bit of a delay, of throttling. So your transaction doesn't start immediately. It takes maybe a second or two as you're waiting for things to go. You might have a period where you've got a lot of extra transactions because it's Black Friday and you have a sale and people are coming and hitting the system. You might have an end-of-the-month report that uses a little bit more data, so where queries take a little longer than they normally do. Instead of failing, as soon as you reach the limit threshold, we're going to let you go past a little bit. And if you don't do any more than that, we're just going to let it keep going on, and everything's going to be fine. So we're not going to enforce you when you get that threshold. We're only going to enforce if you're a repeat offender. So the soft limits feature is going to be, I'm pretty pumped about this. So how's this going to work? What's the new enforcement paradigm? These are going to govern most of our transaction limits that we have today. I talked about the concurrent long-running transactions. It's also going to have, check CPU that's running for the transaction, memory, database use. So these are things we're going to track with an algorithm saying you have reached a certain threshold. So the current limits are going to become thresholds that we're going to start paying attention. That's where we're going to start writing your name on the board and saying, aha, I see this transaction is starting to do more than we really wanted to do. Well, let's let it slide, but keep our eye on it. So the limits are going to be now a threshold, not at which we're going to hard stop enforce, but where we're going to start watching. What's really great about this is we're going to be able to dial it down to a very specific level of granularity per org, per transaction entry points, and also for each limit. So we can say, this visual force page is slow. The rest of your org is totally fine. We don't really care about the rest of your org, but that one visual force page is doing something funky, and that's the one we're going to block. So any other page people go to will not have any sort of throttling take place. It's just that one page. And this way we can let you know what's going on, and you can fix the problems that you've got on the page that we're looking at throttling. What we're going to now do is we're going to create much larger backstop limits. This is the runaway truck ramp I showed you before. These are things where if you've reached our backstop limits, you have probably done something you did not expect to do. That's where we want the limits to be. The actual cutoff limit should be something that this is probably not what you wanted to do. You might want to go fix that, and you're going to say, thank you. Thank you for telling me I did not do something. I did not mean to make an infinite loop, and I'm going to go fix that quickly because it's a bad experience for your users as well as for everybody else in the multi-tenant environment. So the current limits will be the thresholds at which we're going to start to throttle you, and then these backstop limits will be the point at which we're going to cut you off. So what's our attitude going to be? If you do something that's extreme, back in the no limits attitude there, extreme, we're going to backstop enforce. We're going to say you've reached a hard stop limit, which is way at the end of you definitely want to be stopped at that point. Infrequent breach of the threshold, we're going to let it slide. We're not going to do anything. Like the police officer who sees you going 52 miles an hour in the 50, he's not going to pull you over. He's going to let that go. But if you start rolling the stop sign in the corner every single day, eventually you're going to get pulled over. If you frequently are going past the limit, that particular transaction entry point, we're going to throttle. We're going to slow it down, and we're going to make sure that it does not get to consume too many resources, more than its fair share. One other thing to mention is that if you continue to get throttled, there's going to be something, you thought that the queue animation there, if that queue gets too long, we're not going to fill it up anymore, right? We're not going to let you put too many things in that queue. We're going to assume at that point that you've gone beyond what you wanted to do. And if you're waiting in that queue for too long, right, if someone's in the queue for 2.5 minutes, they've probably reloaded their page already anyway. So there'll be a time limit for someone to dwell in that queue as well as an aggregate length of which we're going to let people in there. And if you do get to that point, we will enforce the limits and say your transaction is continually going past the limits, please go refactor it because it's going to continually use too many of our resources. This should be a lot nicer, a lot friendlier for you as a developer, a lot friendlier for your end user, let you do more than you can do today without having to do limbo gyrations to get yourselves under the limit just that one time. So there you have it, Apex no limits. We can't really get to no limits. We need to have some things in place to protect the service. But our goal is to get them out of your way so that you don't have to think about them all the time and so that you can go fly through the air. Thank you very much. So I think we have a little bit of time. If anyone has questions, feel free to hop to the microphones. Everyone else, thank you for attending.
Hello. Hi.
Hi.
Okay. Quick question. Is there going to be anything done about mixed DML that's really a sore spot?
Mixed DML needs to be protected because if you make a change to something that can alter your permissions, how do I know what to do with something else that's affected by that permission in the same transaction?
Could that possibly be maybe an exception in test classes?
I suppose. Is there an ID on the ID exchange for that?
I'll do it as soon as we
do. Thank you very much. Yeah. The video will be online on YouTube. All these sessions are going to be recorded and posted on YouTube. Okay. Yep. Just run around. Yep. Hi.
First, I just want to say that I really like the idea of soft limits. It sounds great, but I was thinking about, I did have a little bit of concern about maybe some more stubborn customers that are going to be in the throttle position quite a bit, and they might see that as just general slowness of the platform. Is there a plan to maybe inform developers that, hey, you're getting throttled infrequently, often, you might want to look at this?
Yes.
Proactive approach?
Absolutely. We will let people know when they're getting near their limits, past their limits, when throttling is taking place, so that people can do something about it.
Yeah, because right now it's really obvious when you hit the limit. The developers know.
I'm also afraid that people are going to say, why is Salesforce slow, rather than why did my developers write code that made it slow? So
exactly.
We will be informing people, yes.
All right, thanks.
Hello. We work a lot with regular expressions, and there is this infamous regular expressions too complex exception. These are regular expressions that work fine in Heroku and Google App Engine. Do you have any update on these?
So the regular expression one, oh man, we just went through this, 2 releases ago we blocked this. I'm trying to remember exactly what that one was. I think that there's something to do with, if you put the right thing in there, it can end up doing some serious CPU usage. So that's why we have that one there. I don't think we have any short-term plans to sort of identify safe complex expressions versus not safe complex expressions. So yeah, that's there. That's a service protection that we've got in place. Yep.
Hey, Josh.
One more question, then we're going to have to call it. So go ahead, Dan.
Okay. One of the greatest challenges I have, especially with CPU limits, is it hits and there's no way to trap it and maybe write some diagnostics, logs, and so on.
Right.
So if, as you're designing this, there was, you hit the limit, there was a way to maybe hit an exception first so that I can then say, oh, I've just hit CPU time limit, let me go ahead and give me a few extra cycles to do a a database write where I can log my errors so I know what happened. That would make life so wonderful.
Right. Problem is, I don't know what you're going to do in that exception handler. You might just keep running.
Right, but then you can shut me down. Yeah. Right, so it's sort of like
a limited exception handler for limits. Something of that nature. If people want to, if I'm limiting your database use and you want to write something out the database, I'm limiting your database use, so I don't want you to write something out the database.
Right,
that's
but
really the issue.
Just, in other words, I'm saying give me one more thing, because I catch it, and then I have one more DML write.
It's my daughter Naomi up there. Just one more video before bed. One more video before bed, right? So.
Right. I mean,
I hear you. I hear you.
That would be really useful.
Again, throw it on the idea exchange, put it out there so people can vote it up. I hear you. You understand why we don't have it there, but yeah.
Yeah.
I hear you. All right. Thanks, everyone.